we are going to sniff helium tanks for excess mercury. The first thing we're going to do is load the tune parameter, the most recent tune file. Click on the folder, opens up the tune parameter file. Sort by date modified. Make sure that the most recent tune file is on top. Choose that most recent tune file. Select open. Coming back up, we're going to now load or create the scan list. Clicking the yellow button there. Coming over to the load, click load. And of course it's already been created. Sort by name. Going to choose the HGPB background SCL. Click open. What we're doing is measuring mass 202, which is mercury only, and mass 204, which is actually mercury and lead. There's an isobaric interference of mercury 204. And we're measuring both of those in the detection mode of counting. So we're using the low counts per second of the SEM. And I'll hit OK. And then I'll come up and hit the green arrow to start the scan. Once it starts scanning, we're measuring mass 202, which is mercury only, and mass 204, which is the mercury interference and the lead signal. Now we're going to break the laser out of the system. I'm going to unscrew the right end of this cap. I'm going to hold the center, that connector between the two caps. Unscrew, righty-tighty, lefty-loosey. Note that the crossbars of the stopcock are perpendicular to the flow. That means that oxygen won't get in the system or air won't get in the system. Grab the tubing from the cylinder and attach this into the mass spectrometer. Hold the center base and finger tight and snug. Then open the stopcock 6 full turns. Now that we're hooked up, we need to go to the gas room. We're here in room 103, which is just east of the E2 lab. We're going to sniff a new cylinder for helium, for excess helium, with this regulator that sits off to the side. Placing the nipple inside the cylinder valve, bringing the threads up to the cylinder valve, and wiggling 360 degrees to get a good seat of the threads. Once you get a good seat, righty-tighty, up to you can't tighten it anymore. Make sure you bring the regulator forward so that you can see your values. Take the wrench from the wall and snug down the regulator. When opening the cylinder, make sure to open it slowly. Because you're hammering the system with high pressure, you want to do that as slowly as possible. Open it quarter turn, half a turn. We have 2,500 PSI. Our pressure valve is decreased and our line valve is closed. We read 0 of pressure going out to the system. I'm going to open the line valve all the way. Don't crank it, just turn it open, and then increase the pressure coming out to 2 psi, no more, by righty-tightying the pressure builder the needle is starting to move. Be very gentle and increase the pressure to 2 psi. So here we are at the mass spectrometer. We're looking at signal in. There is no helium flowing into the system currently. We're at approximately 400 counts per second, sporadic counts on mercury 202, and then the lead, the 204 mass of lead and mercury is around 100 to 200. Quite bouncy signal, as you can see on the integration windows. We're going to watch the integration windows. This is baseline, and when we have enough flow, we'll see an increase in that baseline dramatically. Now I'm going to close the needle valve by righty-tighty. Now I'm going to open the stopcock to the mass spectrometer by counterclockwise rotation to move the stopcock from perpendicular to parallel to flow. I'm now going to open the flow of helium into the mass spectrometer by half turns on the needle valve, lefty-loosey to open. It usually takes 3 full turns to see the signal that you want to see, but always do half turn increments. Making sure to give the flow some time to reach the collector. Hey, there's our signal. The reason I knew that that signal increased was the baseline here and then the dramatic increase in signal. Now that we have helium flowing to the mass spectrometer and we have signal, I want to rescale this window so that we can really see what's happening. We've got 202 mass at 2,500 counts per second, jumpy. 2,200 counts per second is not very much. And 600-ish counts per second on mass 204. The window that I'm interested in is this one. I'm going to drag that open. The natural ratio of 202 to 204, window A, window B, A over B, is 4.3. So we have the natural ratio documented here in that helium cylinder. Now we're going to stop the scan by coming up here and hitting the stop scan button, little red button. Right, now we know our helium is good to go. We'll close up shop and get ready to run. I am going to righty-tighty to close the needle valve. I'm holding the centerpiece and I'm lefty-looseying the cap from the system. Now I'm going to reattach the laser tubing to the mass spectrometer tubing by holding the connector snugly. Do not cross threads and righty-tighty. Once you feel resistance, hold that connector snug and snug it up. All right, now we're done here. We're going to go back into the gas room 103 and disconnect the cylinder. I'm going to turn off the line valve. And I'm going to turn off, when you feel resistance, it's off. And then I'm going to close, righty-tighty, the cylinder. Once these two are closed, take the wrench and release the regulator from the tank. Floating the regulator 360 degrees to find the easiest point at which the threads will unscrew. Now I need to write sniffed and good on the sticker, just like this one has. Now we're going to put the safety cap back on the cylinder. I always go to the left to find the threads start. Once you find that seat, and you screw to the right to install the cap. All right, now that we're done sniffing helium, and anytime you break the mass spectrometer and laser system apart, you have to check signal to make sure that everything is good to go for running. And that is what we're going to do next.